Hi everyone! By now you've worked your way through most of the variable and attribute control charts, if not all of them, and you probably noticed in the attribute control charts they look really similar and they give really similar looking data. And to make matters worse, they all have similar sounding names, which are just a collection of letters. So we've got P charts, NP charts, C charts, and U charts. And they all sound very similar, and you may be thinking, well, how do I tell these apart, and why do we even have 4 different charts anyway, aside from the fact that we have to use the right chart on a homework or an other assignment or an exam, otherwise we get a bad grade. Why should we even care that there's 4 different types? Well, it is important, and I'm not just saying that because I'm the one that's grading all of that stuff, but it's important in terms of the story you're telling with your quality information, because they do actually tell you different things. And so you have to choose the attribute chart carefully depending on who you're working with and what information you want to provide. So to illustrate how the data affects your actual chart and what goes into the chart, let's take a look at some pairs. So here we have 3 very ugly pairs. These have definitely had some hard use. And let's say that these particular 3 pairs are the only bad pairs out of a sample size of 50. So we've got 50 total pairs in our sample, and these 3 are just really ugly. So let's look at them. In this left one here, we have 5 nonconformities, and the nonconformities are any kind of bruises or dents or otherwise something that you don't want on your pair. And so I just did a really quick eyeball count of them, and I count 5 separate nonconformities. You can quibble with me about how many there are offline. But I've got 5 right here. But even though there's 5 different nonconformities on this pair, it is still one nonconforming unit. And it doesn't really matter how many nonconformities are on a nonconforming unit. As long as you have at least one, that whole unit is nonconforming or defective. So that's why we have the 5 nonconformities versus the 1 nonconforming unit. The unit looks at the entire thing. In the middle, we have 3 nonconformities, and we still have the whole unit nonconforming. So 3 nonconformities, 1 nonconforming unit. On the right, we've got 4 nonconformities, including this weird little bump over here, and 1 nonconforming unit. So let's take a look at how that data goes into our separate attribute charts. And just as a quick refresher, P and NP charts look at the nonconforming units. C and U charts look at the total count of nonconformities. So top row here is for C and U, bottom row, P and NP. Now, it gets more confusing because P and U charts, now we're talking about both nonconforming units and nonconformities in those 2 charts, but they are fractions. Whereas NP and C charts are actually total count charts. And that, by the way, is the C chart. That actually stands for count. So let's look at how we figure out what are we going to put down in terms of that number for our subgroup in our calculations. Here we go. So here's the data again from our 3 pairs. Remember, these are the only 3 defective ones out of our total sample size of 50 right here. For a P chart, that is the fraction of nonconforming units. We have 3 nonconforming units out of 50, so that's 0.06, and that is the number that we're going to plot on the y-axis. So we have subgroup, let's say 1, and our y point is 0.06. If we wanted to make an NP chart, we're still looking at nonconforming units, but this time we're actually doing a count of them. So that's just 1 plus 1 plus 1 is 3, and 3 would go on our y-axis. Okay, but let's say, you know what? We are more worried about how many dings are on these little pairs and the fact that the pairs themselves are defective. So we're going to switch to a C or U chart. So when we do that, we count up the nonconformities for a C chart, and that is our total count. So we have 5 plus 3 plus 4 is 12 nonconformities for our subgroup. So 12 would go up on that y-axis. But if we wanted to switch to a U chart and look at the fraction of nonconformities, we still have our count here, 5 plus 3 plus 4, but then we need to divide it by 50 because we've got 50 units in our subgroup. And so remember that U is a fraction base. So it's based on the total number of units in our subgroup. And so here we've got 12 over 50, or 0.24. So that's the difference between those four different attribute charts. And yes, you're going to get similar trends, but what shows up on your y-axis is going to be different, so you're going to have different scales. And this is really important when you're talking to different people with different levels of understanding of quality management. And not only the people, but what do you want to give them? Is the total count of nonconformities more important than the number of nonconforming units? Or is the number of nonconforming units more important than whatever you have in terms of nonconformities and number of nonconformities? And if you're wondering, well, okay, both are important, so how do I tell them both? Well, that's when your quality rating system comes in, and that is next week's video. So we'll talk about that next week, so hang on to that thought. But in the meantime, these differences in your attribute charts are what controls what shows up on the chart. So yes, they look very similar, they tell somewhat similar stories, but you get different information out of each chart. So keep that in mind. What story do you want to tell when you're putting these charts together, and select the appropriate chart for your story?